This is a continuation of a previous video. I'll be disassembling the movement and identifying key defects needing attention. The balance bearing setup may or may not be original. At this point in time, we have decided to leave the bearing setup as is. It's currently running about 30 seconds fast in 1 minute. There appears to be a problem with the escape wheel teeth to pallet surface fit up. Adjusting the pallet using the adjustable pallet bearing won't correct the issue. The condition is causing poor motion in the balance wheel. I'll start by letting down the mainspring. This screw has some type of black anti-corrosion finish on it. Hold it down for the ratchet wheel. Ratchet wheel. Rivet for the click is going to need to be tightened. Somewhere on the mainspring arbor pivot hole. Taper pin for the hairspring has some flat surfaces filed on it. It should be replaced with one that is concentric. Balance staff thrust bearing and hold down for the regulator arm. Screws are mismatched. Balance staff pivots look modified. They should be more flat on the ends. The tapered portion of the staff is rough and has file marks on it. This balance staff bearing assembly should be a snug fit. It's floating around in the hole. This will negatively affect the timekeeping. Not good. This is an unusual setup. Both cap jewel and hole jewel are mounted together. The jewel setting looks to have been silvered. Cap jewel has some adhesive around it. Looks and feels like shellac. It appears to be possibly the same vintage as the movement. Not sure about the originality of this adjustable bearing screw setup. Could this be an upgrade from the factory or modification someone did in the past? And here, there are two plastic type shim washers. Someone has shimmed the plates for some reason, maybe to increase inshake on the gears. Odd. This hour wheel should have a keeper washer on the minute wheel, between the wheel pinion and taper pin. Someone forgot to install it at some time in the past. Minute wheel taper pin. Hour wheel. Minute wheel. There's a tool mark on the surface of the pinion, probably from a tool when someone installed or removed the taper pin. Cannon pinion clutch tension washer is installed upside down. It should be installed with the cup side facing up like this. It's designed to contact the clutch disc on the cannon pinion like this. Here's the machined area on the center wheel arbor for it to nest in. This is the way it was designed to be installed. Installing it upside down has damaged the gold gilt on the front plate, exposing the bare brass. Sad. Once gold gilt is damaged, it's never replaced. Butchered. Center wheel has some movement in the pivot hole. Side shake on the third wheel. Some side shake on the fourth wheel. Escape wheel pivot, pallet pivot, side shake in the mainspring barrel assembly. Every loss at the bottom end of the train will exaggerate by the time you get up to the top of the train. Oh, mainspring barrel is worn and allowing it to tip sideways. This will cause problems with meshing of the train, and in turn stop or reduce power to the train. The teeth are worn slightly uneven to their direction of cut. This is from the barrel tipping sideways. Torque output of mainspring is reduced with this condition. Not sure what causes the gold gilt to have this pattern. I see a lot on early movements. Must be the type of process used back then. Tool mark from a punch used to deform the brass to close the pivot hole. A couple of brass chips. Here it is from a different angle. These tool marks deface the movement for the rest of its life. This one is quite deep. An oversized bushing would need to be cut in to remove it. Another punch mark on the third wheel pivot hole. This is a quick fix. It permanently defaces the movement. Scratches that have damaged the gold gilt. Scratches that have damaged the gold gilt show up as dark scratches. It's from the unprotected brass oxidizing. Clean some of this black oil off to see what we have here. Escape wheel pivot hole. Just look at the scratches. Signs that a butcher was here. The gold gilt is damaged near every pivot hole that has a bushing installed, probably from using a dull reamer, then deburring using a file or sandpaper. Pallet pivot hole. These dents in the plate look like they're from the end of the pallet pivot. Someone probably had a tough time assembling it in the past. Mainspring pivot hole. Loose click rivet. Someone punched the head of the rivet multiple times attempting to tighten it. Black anti-oxidizing finish on it has been damaged from these punch marks. I'll swage the back side of it here, and it'll be good. Looks like someone marked worn pivot holes with scratches. It's best to use a non-destructive process like tape or a marker instead, because scratches are destructive to the gold gilt. More scratches and punch marks next to this bushing. And this bushing is too long, should be replaced. As soon as a little wear gets in the bushing, the pivot could lose its end shake and affect the timekeeping. Some scratches here. Pallet fork. Dirt particles. Impulse face on the pallet is worn slightly. Polishing these out can alter the dimensions of the pallet surfaces. Best to leave alone if possible. Tool marks on the pallet fork arm, not good. They're deep nicks. Adjustment to the fork in these types of movements is made by slightly bending the fork arm. The arm has been weakened and is prone to breaking at these tool marks if adjusted. Look like they were made with a pair of cutters. Fork tail is twisted. An easy fix and doesn't affect the timekeeping. Escape wheel arbor shows some slight rust pitting. The lantern pinion trundles rotate in their mounting holes. These are called rolling pinions. The holes the trundles fit in are round and concentric. They were designed to rotate to reduce friction. This type of lantern pinion was patented by Joseph Ives of Bristol, England. Little is known about this patent. The patent drawing was destroyed with about 10,000 others in an 1836 fire. The swaging of the brass looks good. They're being held in securely. Tip of this escape wheel tooth is chipped. This tooth has been hammered on with a punch, or maybe gripped with a pair of pliers. It's only half as thick as it should be now. This tooth has been smashed thinner as well. Someone has modified these teeth. They are all different lengths and shapes. They're going to need attention. Fourth wheel. I see the lantern pinion end cap has been soldered to the arbor. Most of the time this is a friction fit item. Third wheel. There's zero wear on these trunnions. Might be due to their rotating design. Center wheel. Pinion shows some wear from the main wheel teeth meshing with it. Gold gilt is in good shape. Tool marks on the barrel cap, punch marks and hammer dents. It's been butchered. A lot of wear on this barrel cap. A lot of wear here as well. It's going to need to be bushed. This condition will cause torque and power drop in the train. Too much oil causes dirt and debris to stick. Let's see what it looks like inside. Sad. More deep punch marks. Steel pin for the mainspring hook. Solder joint for the barrel. Barrel is made from sheet brass, bent and fastened with solder. If this was a cast barrel, you wouldn't see any joint like this. Teeth are still serviceable, but show some wear on them. Looks like fine animal hair here. Someone put an X here. These black patches are oxidized brass. It's where the gold gilt is missing. Almost every pivot hole has punch marks, scratches, or an X next to them. Escape wheel pivot hole, adjustable pallet pivot hole, balance wheel jewel bearing, I've captured the mainspring in a sleeve so it can be inspected. Barrel hook is in good shape. Solder joint is nice and tight. There's gold gilt on the inside, but most is worn away. The mainspring has a crack in it here, a disaster waiting to happen. Get this sleeve off so we can take a closer look at the spring. I'll use this rag since the spring is black with grease. The mounting hole is cracked and failing. Here's that crack. Arbor hook looks good. Crack is almost 50% through. When inspecting these, always check the leading edge for defects. All it takes is one small nick to create a crack in the spring. Here's one here. It's small. You can see it snagged my fingernail. Any nicks on the spring should be smoothed out to prevent it from spreading. Time to do a pre-clean on the movement, so I can start fixing the defects found.